Now this figure 20-7 deals with sizing the overcurrent protection device using fuses or circuit breakers when you're going to provide individual protection in the primary. Now you notice if you get over or size, say a fuse or circuit breaker at over 125% in the primary, then you have to put 125% in the secondary when you apply this rule. Now you will find these percentages in table 450.3a of the NEC. Now notice in the illustration, we give you some information there. Service conductors, go to 230.200 for those rules, and you'll pick up your rules for service conductors there. And then the overcurrent protection device for the service is 230.208b. Now, notice when you look at the note for simplicity, table 240.6a is used for selecting your overcurrent devices, and we just use that because we don't have a table listing all these high voltage protective devices that are available to you. Now the voltage is 12,470 3-phase. We have 1,000 kVA transformer here, and notice we have conductors would be sized from 311.60C. And our new tables and the new article 311, tables 311 60C 67 through 311 60C 86, depending on if it's in conduit, cable, whatever you may be running. So we're going to use fuses for this application here, and we also, you see, we have circuit breakers running over. So if we should be using circuit breakers first, then notice that we would apply the step 1 that's in the boxed in information, and we would have 450.3a, which would refer to our table 450.3a. Now remember, Article 450 just protects the transformer, not the conductors. 450.3a in the note would refer you to 240.4 or 240.21 for 1,000 volt or less conductor ratings. But it would send you for high voltage over 1,000 volts to 240.100 and 240.101 to protect the conductors. So remember, we have to look at 240 to protect the conductors, Article 240. And we would look at the Article 450 just to protect the transformer. So step 1, we want to find the full load current rating of the transformer by taking kVA times 1,000 to get rid of the K. The voltage times the square root of 3, so we would apply that. 12,470 times 1.732. When we do our math at 1,000 times 1,000 to get rid of the K and get the transformer into volt amps, we'd come up with a full load amps of 46.3 amp. Now step 2, 450.3a is naturally it's going to refer us over to table 430, or I keep getting into motors, table 450.3a. So 46.3a times 300% is 138.9. So step 3, selecting the overcurrent protection device, and again we just use table 240.6a to keep it simple for you finding protective devices. The 138.9, 300%, 46.3, 138.9 in step 2. We could move up by the note 1 and table 450.3a to 150 amps. But remember, in step 2, we selected that 300% from table 450.3a at the very top of the table there with the percentages for individual. and we would have in the solution 150 amp device. Now, if we should use fuses now, step one, calculating the full load current for time delay fuses, 450.3A again, and table 450.3A, we would take the 46.3 amp primary full load current rating times 250% for a fuse, again, which we selected from table 450.3A. When the math is performed, we come up with 115.8 amp. Step two, we select the time delay fuses, and again we use table 240.6A, and 115.8 amps permits 125 amp to be used because the note lets you round up to the table 450.3A. So the solution, the size time delay fuses are 125 amps. But now notice, if you really wanted to size these fuses in accordance with standards that would list such devices based upon the system being over 1,000 volts, use ANSI C 37.46, and you can pick up these standard protective devices for systems rated over 1,000 volts. Now, that's exactly what this figure 20-7 is illustrating. Determining overcurrent devices using fuses or circuit breakers based upon individual protection of the transformer. Now, to protect our conductors, which we'll get into later, we have to go to Article 240. This is something that we really want to remember.